Hey, welcome everybody. Hi, I can't see you, but I hope you can see me and I hope you can hear me. I'm Suzanne McDonald. I'm the RCIScience Program Committee Chair and I'm the incoming RCIScience Chair. I'm also a professor at York University. And I want to welcome you and thank you for joining us tonight after a long day of, I'm sure, something weird, some weird pandemic COVID day that you've had. And we're here to have our book club, which is a super fun way to finish the day, I think. So this idea of a book club started as a way to engage with science as a community, even though we are in these socially distant times. So it's a way that we can actually talk about science together. You can learn more about our book club on the website. So in the chat box, the moderator is going to be sharing website links and all the information that I'm talking about. And if you would like to, you can join our Facebook group, which is also be linked in the chat box. And stay tuned for after the discussion to hear more about our fall reads, and you can also check it out on our website. So our book today, or tonight, is Pandemic. Geez, I can't imagine why we chose that. It seems like a pretty obvious choice for 2020, pretty timely and important book. It's a great book. I loved it. I learned a ton. I hope you did too. If we were having parties, I would be boring people about that right now, but we're not having parties, but I guess that's part of the chat. So our discussion tonight is, I hope, going to be a lot of fun, but we do have to abide by the rules. So I encourage everybody to, if you have comments, questions, share them in the chat box. Or you can tweet us on Twitter at RCIScience, or you can email us at information@rciscience.ca. So please, any questions, comments you have, please do share them. That's what we're here for, and that makes it more fun. And please do be polite and respectful. We do have moderators that won't be monitoring the chat box, so don't make them remove you from the discussion. So first, I'm going to introduce and hand it all over to our discussant, the person to lead our conversation tonight, and that is Dr. Deborah Foster. She's a professor of biochemistry at Ryerson University, and she's a trustee on RCIScience. Deborah teaches courses in advanced biochemistry, infection and immunity, and host pathogen interactions. Her research focuses on understanding the molecular basis of pathogenesis of several gastrointestinal pathogens, and how the microenvironments within the human host, that is us, influence pathogen virulence. So you can, I'm sure you'll agree that Deborah is the perfect person to lead our conversation. So I'll hand it over to you, Deborah.
Thank you very much, Suzanne. So welcome everybody, and I'm looking forward to this event very much. And it gives me great pleasure to introduce our author of Pandemic, Sonia Shah. Sonia is a science journalist and a prize-winning author. Her writing on science, politics, and human rights has appeared in the New York Times, the Wall Street Journal, Foreign Affairs, Scientific American, and elsewhere. And she's been featured on Radiolab, Fresh Air, and TED.com, where her talk entitled 3 Reasons We Still Haven't Gotten Rid of Malaria has been viewed by over 1 million people around the world. Her book entitled The Fever was longlisted for the Royal Society's Winton Prize for Science Books, and her latest book, The Great Migration, was released in June 2020. So today we'll be talking about her book entitled Pandemic, which was named a finalist for the Los Angeles Times Book Prize and the New York Times Book Review Editor's Choice. So Sonia, welcome, and thank you for being here.
Great to be here. Hi, everyone.
Hi. So what we're going to do is start with some questions that I have for you. And the very first one is, can you tell us what motivated you to write this book?
Right. Well, let's see. I started writing the book around 2010. This was when we had just had that big earthquake in Haiti. And following the earthquake was an eruption of cholera, which was this disease that hadn't been seen in the Western Hemisphere for like 100 years. I had just finished writing a book on malaria, which is, of course, one of the humankind's oldest pathogens. And then it just seemed like we were getting into the situation where all these old pathogens were reemerging in new places, and also new pathogens were emerging. We had a highly virulent form of avian influenza, scares of the late 90s. My son actually contracted methicillin-resistant Staphylococcus aureus, MRSA, or MRSA, as they call it here in the States. And, we went to the doctors to ask them about these new pathogens, and no one really seemed to know what to do. So it just felt like there was this new thing happening. And I started kind of digging around, and I learned that, in fact, there was many new pathogens that are spilling over into human populations at that time, that had started really back in the 1940s. And we're starting to, cause new outbreaks and starts to spread in new ways. And there's this rising fear among experts that a pandemic of the kind that we're basically living through now was sort of, in the works. And so I set out to really figure out why that was happening. How does a microbe that, is a harmless inhabitant of its natural environment, whatever that is, turn into a pandemic causing pathogen? So what are the kind of environmental and social and political drivers? So that's really what I wanted to capture in this book.
That's great. And that actually leads me into my second question. So you speak about how the disruption or destruction of the ecological balance within the environment is often the root cause of a spillover event that can trigger a human epidemic or pandemic. It was particularly interesting to read in chapter 1 how the bacteria that causes cholera, namely Vibrio cholera, once lived peacefully in the shallow, warm, brackish waters of the Sundarbans, a wetlands area along the Bay of Bengal. But in the late 1700s, early 1800s, when that region was dredged and converted for agriculture and human habitation, those human interventions likely triggered the first spillover event causing Vibrio cholera to infect humans. So could you talk about these types of environmental disruption activities that are often at the heart of outbreaks of new human pathogens?
Yeah, so since 1940, we've had maybe several hundred, at least 300 new pathogens, either reemerge into new places or just emerge anew. And I'm talking about Ebola in West Africa, Zika in the Americas, new kinds of tick-borne illnesses like Lyme disease and others, new kinds of mosquito-borne diseases, new antibiotic-resistant pathogens. The list goes on, including all the coronaviruses. And about 60% of those originate in the bodies of animals. About 70% originate in the bodies of wild animals. So why is that? Well, most of our most lasting human pathogens similarly originated in the bodies of animals, particularly animals that are most related to us, so other mammals. And it's easy to see why when you think about it. If you provide a microbe a new habitat to live in, and you introduce it again and again, it'll slowly start to adapt to the human body. And when it does that, if we don't have immune defenses against it, then it can become pathogenic. So in the case of cholera that you mentioned, which is sort of one of the historical diseases and pandemics that I track throughout the book, because it's one of our most successful pandemic-causing pathogens. Cholera has caused 7 global pandemics, one of which is going on right now. So cholera, is usually a marine microbe. It's a normal inhabitant of places like the Sundarbans and the Bay of Bengal, where you have warm, brackish waters. They're half salty, half fresh. And it kind of helps to recycle nutrients in that environment. And people didn't really live in places where there was a lot of, where they're exposed to that kind of water a lot, because this was around wetlands, coastal wetlands where there's swamps or there's mangrove forests or things like that. And people didn't live in places like that for a long time. So we didn't have cholera until the 1800s. And it was related to the fact that people started settling wetlands, cutting down mangroves. And, as they get exposed to that brackish water, they get exposed to that microbe again and again. And the microbe starts to adapt to the human body. But of course, cholera bacteria in its natural environment, in coastal waters, is a useful part of the ecosystem. In the human body, it performs a very different function, which is that it lines the interior of your gut and it reverses the normal functioning of that organ, so that instead of replenishing the body's tissues with fluid, cholera will extract all those fluids and expel them. In massive diarrhea and vomiting. And that's how the microbe spreads. So the microbe is just coming up with new ways to live in new environments, which is just what microbes do, which is what all living things do, right? But as we are cutting down and invading more and more wildlife habitat, we are creating more opportunities for the microbes that live in animals' bodies to cross over into ours, whether it's cutting down trees so that the bats that used to roost in those far forests come and live in our gardens and in our farms instead, and then you have your kids playing outside, maybe they get a little bat poo on their hands, they put their hands in their mouth, and that's a spillover event. If it happens enough times, that microbe will find this nice new environment inside the human body, and if it can survive in there, it'll start to adapt and evolve. And that's what's been happening over time with increasing frequency, because we are destroying so much wildlife habitat. So we're creating that interface between wild creatures and human habitations.
Yeah, I think that's a very important point. And I think that probably has been a revelation for quite a few people in reading about that in your book. So thank you. The second thing I'm going to ask you about is you talk about two concepts in your book, one called confirmation bias and the other one called change blindness, and how both of these attitudes or mindsets prevent people from accepting new truths, no matter how convincing the evidence. And by way of example, you provide us with this one, which I find fascinating and in a way tragic, because in the late 1800s, the same set of attitudes led the city board and the medical community in London, England, to reject Dr. John Snow's scientifically based proof that cholera was caused by contaminated water rather than bad smells, or what they called miasmas. Because there was so much invested at that time in the theory of these bad smells or miasmas causing infections like cholera, it was difficult for people to accept a paradigm shifting premise regarding cholera. And I wondered if you could talk a little bit more about these attitudes and what parallels you see in the handling of the COVID pandemic today.
Yeah, I mean, it's fascinating. It's also interesting how we kind of changed the history over time. Nowadays we think of John Snow. He ended cholera in London in the 1850s. Well, he really didn't. I mean, he tried. So at that time, there was a conceptual framework, which we know of as a paradigm, that the way contagious diseases functioned is that they spread through these, climatic events or clouds of smelly airs that could rise up from, say, decomposing organic waste and things like that. And, that probably made a certain amount of sense for some old diseases, maybe like malaria, which isn't carried by stinky airs, but certainly rises up in places where there's wetlands and decomposing organic material and things like that. So you had thousands of years of everyone kind of fitting in all of the facts around them into that conceptual framework of miasmatism. Then John Snow comes around and he's an anesthetist, right? So that was what he was famous for. He studied gases. So he knew that, well, the way people are getting sick from cholera is not like something that you breathe in. It's not ruining your lungs. It's affecting your digestive tract. So it must be something you consume rather than breathe in. So he had that insight to begin with. And then he very carefully did this sort of empirical study and this novel kind of way at that time of figuring out, well, the people who are all getting this disease actually are drinking this contaminated water. But it just didn't make sense in the broader scheme of how everyone had understood diseases to function for so long. So it was sort of like an inconvenient fact, and I think there's a lot of those inconvenient facts. Once we have a paradigm about how things work, then, we have anomalies that happen, unexplained facts, unexplained evidence. We can't quite fit it into like, how does that work in the general theory of how we think we understand things. And we tend to dismiss those or marginalize them. And that's what happened to John Snow. He died without anyone recognizing, the huge impact of his work and that he was right about cholera. No one believed him at the time of his death. I think the Lancet didn't even write him a proper obituary, which is amazing to think of today. And I think we have paradigms today too. I think we have a paradigm that we fit all of our ideas about contagious diseases into, and that's the paradigm of sort of the invasive germ, which is basically germ theory, right? Like that microbes were kind of these uncontaminated, pure bodies, and these microbes come out from somewhere else and they invade you and they make you sick. And the cure in that case is to get rid of the microbe, right? You kill it with an antimicrobial, or you protect yourself somehow so it can never get into you with a vaccine. Yeah. And that theory, that's a paradigm. It works because it gives us useful information, right? It helps us actually take action, and those actions have helped us for a long time. Antibiotics, vaccines, those things actually work. But I think it's a paradigm that also has blind spots. So, this whole idea of us being these passive victims of external foreign germs that encroach upon us, that helps us come up with the political will to say we must have a vaccine, we must have a drug, we must have chemical weapons to get rid of these pathogens that we don't want. But it also invisibilizes a lot of other things, right? So there's a lot of social and political and environmental factors and drivers of contagious diseases, and we pay much less attention to those, even when it might work better if you were to say you were to protect certain wildlife habitat because that, okay, those animals, we don't want to have a lot of contact. We want them to stay in their part of their wildlife and not, have these crossover events all the time. That might be extremely effective because it would be in a small scale. It would be preventive. You wouldn't have to wait until you have this huge outbreak to then, clean up that huge mess. But it really doesn't fit into our paradigm of how you think about infectious diseases today and how we then respond to them.
Yeah, I think that's a great point that you make. So the next question I wanted to mention is, you speak about the influence of previous pandemics on our bodies, our responses to modern diseases, and how our genomes contain evolutionary clues about pandemics from our past. So I wondered if you could expand on this effect of pandemics on our genomes and what we can learn from it.
Yeah, and this was one of the most fascinating parts of the reporting for this book, was learning about how much our bodies have been shaped by other pathogens in the past. And I learned a little bit about that from malaria, which of course has shaped our, many of the red blood cell genetic conditions that people have today were actually evolved in reaction and response to malaria's appetites, the most famous being sickle cell, of course, but there's lots of other ones. And, and then you think about how much disease we have today are shaped by genetic risks factors, right? And usually if you have a genetic mutation that makes you more vulnerable to kidney disease, or makes you more vulnerable to tuberculosis, or makes you more vulnerable to COPD or something like that, those are things that would generally tend to not spread very far in human populations. And yet we see today that almost all of our diseases have some genetic risk factor involved in it, right? And I think increasingly what scientists are understanding through these genome-wide association studies and others is that some of those genetic mutations probably arose because they were useful in fighting off and warding off some other old pandemics. So they're sort of like the little, footprints of pandemics in the past in our genome that we still have today. And we have this kind of hangover of they cause us some problems now, but we had to, in a way, the way I think about it is like it's almost like we had to deform ourselves a little bit, to accommodate the appetites of the microbes that, we share this planet with.
That's right. I found that a fascinating part of your book. I really enjoyed reading that. Okay, I'm going to switch to talking about the current COVID pandemic. And my first question on that is to ask you, what surprised you most about it?
Right. So most everything was what I would have expected if I, what I wrote about in the book. But I think the thing that no one expected and no one even gamed out, when people were kind of planning, like, how would we deal with a pandemic, is the absolutely chaotic and disruptive response of the United States in particular, but also other regimes that are led by right-wing populist leaders. So like we have this crisis of governance going on at the same time that we have this biological catastrophe of the pandemic. At the same time that we also have a climate crisis that is increasingly making itself known. So that I did not expect. You know, I don't think anyone gamed that out, that like, okay, when you have a pandemic, you'll also have a governance crisis and you'll also have a climate crisis at the same time. And all of these different crises are kind of amplifying each other and making it more difficult to address the pandemic. I think that's the most unexpected aspect of it.
Yeah, I think that raises a very good point. I agree with you. I think the other thing that probably the world was surprised at is how profound this pandemic was in terms of how it affected our lives. I think we had been lulled into a sense of, well, here's how we dealt with SARS, and likely this is another coronavirus, this is another respiratory virus, we'll handle it as we handled SARS. And we all managed, and it wasn't so devastating. Whereas I think people are now shocked by how serious this pandemic is and how devastating it is. I also wanted to ask you, how do you think the COVID pandemic and our responses to it, which feeds off your last question, question, how do you think that that's going to shape society, and how do you think it's going to change our behaviors?
You know, it's interesting that you asked that. I mean, I think the disordered response of world leaders, like in the United States, I think is one of the main reasons why we've had so much virus around, especially in the industrialized world. And I think that's very unexpected. So it could have been something that was much, was contained like the way it was contained in China. Like that could have happened in Europe, that could have happened in the United States. We probably still would have seen big outbreaks in South America and places where there's been long-standing problems with governance and big society, large populations. But we're used to that. So, I think the thing that's interesting about this pandemic is that populations who have never had to live with the risk of a disease that you don't understand well and that there aren't any good treatments for in your life every day, and there's a lot of people around the world who have been living that way for centuries. There's a lot of people in the world who are living at the complete whim of malaria, of cholera, of tuberculosis, of HIV, of all the other old diseases that those of us in the industrialized West, we don't really even have to think about that deeply. And now we're having to deal with that, being exposed to that level of risk. So that's really what's new, I think, about COVID-19. Sorry, what was the second part?
How you thought it would change our behaviors.
Oh, changing our behavior. Oh, right. Well, so, it's interesting because when it first started, I thought, everyone thinks it's going to change our behavior. And I felt like it was almost like we were grasping for straws of like almost, like really wanting this to be transformative because it felt so new. Because we erase our history, right? But if you look at the history of outbreaks and epidemics and pandemics, usually what happens is we experience them, they pass through our populations, and after we survive, we go right back to business as usual. Yeah. And that's why pathogens have been so successful for so long, right? We had cholera outbreaks in the United States like for 80 years, again and again and again and again, and we just kept going back and doing the same thing again and again and again. The only reason we got rid of it is because the brewers and other industries that didn't, were competing for market share didn't want their water to taste bad anymore. And so they wanted fresher water. And that's really what led us on the path of having safe water and clean water that got rid of cholera.
Yeah, so that's a very interesting part of that story, isn't it?
Yeah. So it's we really just live with them. We kind of tolerate and sort of make do, and we don't really, our bodies are changed by them. Our bodies are marked by them. We accommodate them more than we actually respond to them. So it's hard for me to say exactly how we're going to change. I think we're going to change not so much in response to the pathogen itself. I mean, the rational things to do would be to, rethink how we do housing, rethink how we do group activities, rethink how we travel around, rethink screening, rethink public health support and infrastructure. Those would all be rational responses.
Exactly.
Right. I don't see that necessarily happening in any kind of linear fashion. Maybe by mistake it will. You know, it's interesting when you think about the Ebola outbreak in West Africa, and 11,000, 12,000 people died. And it would have been worse with the second, you know, and then we had another outbreak in Africa. But for that one, we had a vaccine. And the only reason we had an Ebola vaccine that was that far along that we could roll it out at that time is because after 9/11, there was a huge, you know, scare, like a panic about bioweapons.
Mm-hmm.
And we had this huge program to come up with vaccines against what might be used as a bioweapon. And there was this idea in the US government that Ebola might be used as a bioweapon. And so we had this whole Ebola vaccine program. Well, it wasn't useful for bioweapons at all because no one's ever been able to come up with a bioweapon that's any better than what nature can come up with. But then, you know, all these years later, it becomes quite useful for the Ebola outbreak. So I think, you know, I see those kinds of changes more likely when you have, you know, just the changes that are not rational. They're done for one reason, but then they have some other effect, you know.
Right.
And I think we're going to make those changes not in a rational response to the outbreak, but probably more in response to the containment efforts. You know, I see the containment efforts really shaping people's ideas about, you know, governance and political control and who gets to tell me what to do. You know, all of that, I think, is going to have a more lasting impact.
Mm-hmm. You raise a good point. Thank you. Okay, so I now wanted to talk about different kinds of pathogens. So when we typically talk about pathogens, I think most of us are aware and fairly respectful of bacterial and viral pathogens. We've encountered them throughout our lifetime, whether it's been for vaccinations against diseases like diphtheria, whooping cough, or even viral flu shots every year, or even through personal experience, living through chickenpox or having strep throat infections. However, an important point that you raise in your book is that we tend to underappreciate the risks posed by fungal pathogens and how they can pose new dangers for us in the future. So I wondered if you could talk a little bit about this idea and what dangers we might face from fungal pathogens in the future.
Yeah, I mean, it's a little bit speculative, but I think the theory behind it makes a lot of sense, which is that you know, there's this question about why are we warm-blooded, right? Why did we evolve to be warm-blooded? It's very costly to have to heat your blood up to 98.6 degrees all the time. You know, we have to eat a lot more, and we have to metabolize a lot more, and all of those things are like really costly. So why did warm-bloodedness evolve? And one theory is that you know, if you're cold-blooded, you have a lot more fungal pathogens, right? Fungal pathogens live in the environment. So they are adapted to the ambient temperature. And if your body is also the ambient temperature, then they can more easily occupy your internal tissues. And so we see a lot of fungal pathogens in plants and reptiles and other creatures that don't have warm blood, but you don't see very many fungal pathogens at all in warm-blooded creatures. We have a handful of them that are problems for us even right now, compared to, say, how many fungal pathogens there are of plants, for example, where there's a huge, huge problem for plants. So one theory is that warm-bloodedness may be evolved for that purpose, right? Because it saved us from the appetites of fungal pathogens. Well, fungal pathogens are in the environment, and they are going to be adapted to the ambient temperature. What we're doing right now with climate change is the ambient temperature is getting higher and higher. So as those fungal pathogens get adapted to warmer and warmer environments, that difference between the temperature of our blood and the temperature that they can withstand gets smaller and smaller. And will that potentially lead to more fungal pathogens that are able to live inside of our warm bodies? And it seems that already that, you know, so this was a theory, and I think it's a very interesting theory. There's some evidence that we do have a higher frequency of certain fungal pathogens that are already starting to come up. So we'll have to wait and see. But, you know, if the fungal pathogen decides to come after us too, then, you know, that's like a whole other level. It's going to be a whole other level of trouble.
But I think it's a really underappreciated or under-respected area of pathogenic microbes. So I think it's an important thing. So what I'm going to do now is suggest that people who are watching, please start submitting your questions in the YouTube comments, Facebook comments, or to information@rciscience.ca. So if you could maybe send your questions in, that would be great. Okay, the next question I have for you, Sonia, is throughout your book, you talk about the importance of learning from our past experiences with pandemics and how in many instances we haven't done very well with this. Taking, for example, SARS, which was another respiratory illness, and we mentioned it earlier tonight, and one where we had firsthand experience here in Toronto. What lessons should we have taken away from previous pandemics like SARS or even like the 1918 flu pandemic?
I mean, now that we're actually experiencing a pandemic, it seems that, you know, a lot of the lessons we could have learned, we still have. It's just we didn't have any political will to implement them. You know, we have a whole system of, we know how to do this, like, right? You know, we know how to screen for this kind of pathogen. And we came up with those developments like so quickly after COVID-19 emerged. You know, we had the genetic sequence really quickly. We had diagnostic tests really quickly. Like we had all that stuff ready, and WHO and like other experts told us what to do. You know, they told us what to do. You test everybody and you trace their contacts and you isolate them with support. That would have worked in the places that did it, but you know, we just didn't have a coordinated response. So it's a real failure of collective action. I think we had a good idea after World War II of like bringing countries together and coming up with a system of collaboration. And, you know, the whole WHO and UN system really started back with the International Sanitary Conventions, which were all about controlling cholera and making sure that, you know, when you send your ship to my port, you tell me if the passengers on your ship have cholera, you know, so I can quarantine you. And that was really the whole basis of it. So it's just such a tragedy that we didn't use that knowledge and infrastructure that we had in place. So we could have done a lot more with that. And I blame the politics of the moment for the fact that we didn't. The other part of it that we should have understood better, and I think many people did, but it was just not enough scale, not enough funding, not enough political will and urgency around doing these things, which is finding out, you know, trying to find the next pandemic causing pathogen by tracking microbes that are spilling over into human populations, you know, at that human wildlife interface. So, you know, hunters, people working wet markets, you know, people living in slums where there's a lot of, you know, flight networks, you know, different aspects of the drivers of pandemics that were well understood. And, you know, you can't surveil the whole world for every microbe, but you can certainly look in those places. And people were doing that. There were scientists who were doing that. And it was literally like in the tens of millions of dollars. If, you know, this is like peanuts considering how much benefit we could potentially get from that. But the other part of this is human nature, which is that, you know, when public health succeeds, nothing happens. You know, so the big accomplishment is nothing happened. You didn't have a pandemic. You didn't have an epidemic, right? So you don't have that built-in, you know, the positive feedback cycle of like having this big success that people can see. So getting the political will to keep all those things going in the absence of some kind of, you know, big heralded victory, I think it's very difficult. You have to kind of build it in from the bottom up, you know, like clean water. We all think of that as like our entitlement now. Well, it wasn't that. That wasn't true 100 years ago. We had to fight for it, you know, and we were sick for a long time before we got that. And I think we have to think about all these other things in the same way. Like we need people to be looking out for the new microbes that are going to come down the pike. And we need a public health surveillance system that works across borders. You know, that should be something that we feel as citizens that we must demand for our own safety and security.
What shocks me so much, being part of the infectious diseases scientific community, is we have known for years, and we've been hearing about this concern, this serious risk that we all faced of a coming pandemic. We knew that it was going to happen. It was just a matter of when. And yet I felt that we were so ill prepared for it, even though we have had so much history of dealing with pandemics. If you look back and if you read anything about the 1918 flu pandemic, and you read about what they had to learn and what they had to go through, and it feels like we're having to go through all of those lessons again when we should have benefited so much more from those experiences that we lived through before. So, and the other thing that I must mention, when I first start, I think your first chapter opens up and you talk about visiting a wet market in China. Is that right?
Mm-hmm.
And I remember as I read that very first chapter, and of course you were writing this in 2017, you published it in 2017.
Mm-hmm.
And yet here we are, and we were hearing about exactly this concern associated with the outbreak of COVID-19. So it was quite eerie to open the book and to begin your first chapter and read about the wet markets there, and to hear about how they're set up, and to hear about the potential for transmission of infection through those cages and among the animals. So that was quite alarming to think about that. Okay, we do have a question coming in from a viewer. North Korea hasn't reported many cases, but do we want to live as they do there for prolonged periods? And how do we balance lockdowns with quality of life?
I mean, I think you've got to the heart of the issue. And I think what we need to do is we need to be ahead of the virus. Right now, we're constantly playing catch up. So if you're constantly playing catch up, then all you can do is contain outbreaks as they're happening. And by that time, the pathogen is already spread outside of your little containment zone. So you need to get ahead of it so you know exactly where it is. And then, you know, you can do the testing, you can do the tracing, you can corral the pathogen, and you know this is where it is, right? And so everyone else, so right now, since there's so much virus around, we all have to act like everyone around us is potentially infected. That's how we have to act. So that is hugely costly for our social life and our development and, you know, the functioning of our societies, as all of us who have lived through, you know, the hard shutdowns of these past months now recognize. If we had done that and gotten the virus to a really low level, then it's conceivable that we could have known where it was. You know, if you keep tracking where the virus is going, then there's going to be a lot of people who can act, you know, normally around each other and can function normally. Right? We don't have to guess. We don't have to pretend that, you know, our neighbor and the student in our class and our, you know, and our friends and everyone else is potentially infected, because we'll know where the virus is. So I think the trick is getting the political will to do a hard shutdown or something so that we can get the virus to a really low level where we can actually watch it. If there's just a lot around, then it's very difficult. In the United States, we have 40,000 cases a day. Every day, we have 40,000 new cases. It's insane. It's such a huge level. You can't trace and track everywhere the virus is when you have that much virus around. But if you're New Zealand and you only have 2 or 3 cases, right, you can keep screening people and making sure that, you know, when the virus comes in, which it will, you'll know who has it. And then the rest of society can function, you know, semi-normally.
Yes.
But we just haven't gotten to that point.
Yes, you raise a good point. I mean, New Zealand has done a terrific job in trying to contain it and trying to track infections through its population, and they've been able to really keep the lid on that, on the spread of the pathogen. Okay, I have another question coming in. Why do you think that science is losing these communication battles? We have a wealth of experience dealing with pandemics, and yet politicians are increasingly insensitive to the risks. Okay,
so this is, it's very easy to blame people like, you know, Donald Trump because he's anti-science. And of course he is. But I think there's a deeper lesson from what's happened here, which is that we've had all these populists come into power by saying, you know, the whole idea of a populist is that they're anti-elite. You know, they are of the people, and they don't care about what the elites are doing, and they're going to do it their way. And, you know, they're doing it all for you. That's sort of the populist brand. And I think a lot of populists have taken science as elites also. And so part of their brand then becomes, well, we're not going to listen to those pointy-headed scientific elites with their advanced degrees and fancy, institutional affiliations and all of that. Those are elites, and we are populists. So these two things then become sort of diametrically opposed. And I think there is a way in which the scientific establishment has contributed to that. In part, it's because of the way science functions. But I think in part, it's also because, scientists have been very reluctant to engage on, in the civic life of societies. And I think that's what needs to change. So we need to democratize science so that populists can't say, oh, the scientists that's just elite opinion. I don't have to listen to that. Those are those far off elites. They're out of touch with the common man. We can't let them make that argument. We need science to be for the people. So we need a lot more science education, of course. I mean, the huge illiteracy, scientific illiteracy of the majority of the population in many countries is a huge problem that we need to address. We need to make science education just, embedded in from the very earliest years of when we educate our children. But we need scientists also to involve, the rest of us so that we can all be, a part of it. I mean, I think the gatekeeping that you see in a lot of science where you say, well, there's lingo, there's all these ways of talking that shut people out, that as if these concepts are just beyond, the everyday person. And so, some of them may be, but a lot of them are not. In a lot of ways, science can be communicated to everyone else. We can be part of making science. There's citizen science, which is happening now, which I think is like really positive. There's scientists who are getting involved in the political process, which I think is hugely positive. But I think we really need to think about science as something that, is for everyone and not just something that, only experts can do.
Yeah, I think you raise an excellent point. I do think at the university level, at least, I've been seeing a lot more emphasis on scientific communication as an important skill for students to learn. So I do think that we are seeing at least the evolution of changes in the educational system to try to improve that. And it's funny that you should mention this about scientific communication, because the next question is, do you think the medical community needs to rethink how they relay information and communicate facts to the public, considering the massive amount of misinformation dominating social media?
It's a multi-pronged problem. So it's not just one sector of society that needs to deal with this. But yeah, I think we all need to play a part. And to me, what's happening here in the United States, where I am, is absolutely about a failure to provide accessible education for people, so that they are just able to absorb misinformation and don't have anything else to kind of compare it against. I think from the biomedical community, we need much more engagement with people on the ground. I mean, you see like the vaccine debate, for example. A lot of times when people refuse vaccines, you get this response from the biomedical community as if they're dumb, like they're ignorant. They don't understand. They're so stupid. They don't understand that vaccines work. And so we're just going to have to like wag our fingers at them and tell them. And that spills over into, how people even talk about anti-vaccine sentiment, that those people are, just somehow ignorant or stupid and that they don't have any legitimate claims. And, I'm not saying that they do, but at the same time, you have to take people seriously. And I think there is a way in which, people are afraid of vaccines for legitimate reasons, right? You have that breakdown of trust in the biomedical community because there's been transgressions in, clinical trials that people have heard about. There's been corporate influence in medicine that people have heard about. There's been secretive, there's been like chemical companies and drug companies have been very secretive in a lot of ways. All of these things contribute to a lack of trust, an erosion of trust. And so then when the biomedical community comes in and says, no, you better take this shot because I said so and I'm the expert, it doesn't work so well. You have to get back down to actually rebuilding the trust between people and the biomedical community. And some of that is messaging, but I think it's also something even deeper than that.
Yeah. And I think this raises another point about the importance of the medical community taking their time to develop an effective, safe vaccine. I mean, I know that there's a lot of push to try to get the vaccine production out right away. And we hear indications that we'll have a vaccine by the end of October or the end of November. And then we hear from a lot of medical experts saying, no, that's far too soon. We need a lot more time. And it is important for them to take their time and make sure that they've got a safe and effective vaccine. And so I think that speaks too, as well, to the importance of gaining the public trust, in terms of developing a safe, effective vaccine. So the next question that's coming from our listeners is an interesting one. In your book, you discuss cholera parties in which Parisians gathered and danced cholera waltzes dressed as corpses. Are you seeing any parallels now? Where are people being fatalist and throwing caution to the wind and gathering without taking proper social distancing precautions?
Yes, yes, I'm seeing it everywhere. I think we all are. And it's, at least in the time of cholera, they really didn't know how to avoid it effectively. They had ideas, don't eat watermelon or, things like that. But, there wasn't any consensus on how you really avoid it that everyone believed in. So the fatalism, at least in that moment, made a little bit more sense. I think today it's just, it's even more irrational. Except, I think the other part of the story of COVID-19 that's not being told properly is just the story of risk perception and how people behave according to how they perceive their personal risk. And that is legitimate, that is a legitimate decision-making process that people go through all the time. We have to sort of understand it and respect it and then work with it. And I think, I don't think we've done that effectively. So I think we've told young people, for example, that, they need to sacrifice even more than, say, someone who's older who stays home a lot anyway, right? And yet their actual personal risk is maybe less than the older, So there's all these kind of contrasts that I think make it very difficult for people to make decisions that are reasonable for them, but also reasonable for everybody else. So we need to have that kind of a bigger conversation about who takes on the burdens and who gets the benefits and how do we perceive the risks and all of that. And I don't think we've really done that adequately.
That's good. Thank you. Another interesting question coming in focuses on a different type of pathogen. It focuses on prions. So it says, do you know if there is any concern of another prion disease like chronic wasting disease jumping from animals to humans, such as BSE, mad cow disease, appears to have done?
Yeah, I mean, I have not heard about new prion diseases for a while. And it's interesting that mad cow's disease was one of those, there's a few different diseases like that. I mean, toxic shock syndrome was not a prion disease, but similarly driven by market practices. And that then were very, effectively curtailed by changes in the way companies did business. So it'll be interesting to see. But I have not heard of more prion diseases. Although, to be fair, I haven't been subscribing to ProMed Mail. If you want to know about all the latest outbreaks of weird pathogens around the world, you have to subscribe to ProMed Mail. You can look that up and get the email address for it.
Okay, good. That's a good tip for our listeners. Okay, the next question coming in from our listeners. Any thoughts about what travel might look like in the future? Will we be globetrotting on airplanes and cruise ships ever again?
I think we will. Yes, I think we will, because so much of the economy depends on it. Not because it's necessarily, reasonable in terms of how to deal with COVID-19, but every outbreak we've had, it reaches a crescendo and then it starts to collapse on its own. It's just going to take a really long time because this is something that can infect everybody and nobody has any immunity. So it's going to take a while to work its way through unless we get a safe and effective vaccine that can kind of jumpstart that process. So in the meantime, I think it'll be difficult, but over time, in the broader view, I think we definitely will continue to see, international travel. I think we're going to have international travel. I mean, look at what's happening with the climate crisis right now. People have to move. People are going to have to move to all different new places where to live. All of the West Coast right now is on fire. Those places are becoming, closer and closer, getting to the point of being uninhabitable. You see islands, there's 5 hurricanes right now, heading towards the Caribbean islands. So people are going to have to keep moving. Whether we're going to do as much leisure travel in the near term, possibly not, because a lot of the companies that facilitate that are under so much financial stress that they're not necessarily going to make it through, the end of the pandemic when people start feeling safe again. But I think those companies that can hang on or reemerge after the pandemic sort of starts to collapse, I think there's just going to be a huge appetite for travel because we're all connected, and I think the benefits of our connections are generally greater than the costs.
So you don't think that we're going to be seated far apart in airplanes from now on, at least once this pandemic hopefully is under control? Do you think that we'll go back to being crammed into those economy seats side by side? Do you think we'll be going on cruise ships and having these open buffets with everybody helping themselves? And of course,
we still are doing that. So yes, I think we will, because there's enough people who still want to do it, and there's companies who can make money doing it. So as long as that's true, it'll continue, unless there's actual governance that says we're going to regulate this practice. Right. And that's only going to happen if there's enough political will among, the populace and voters to say, like, we don't want this to happen anymore. And I don't see any of that actually congealing in any real way. So, it would probably make sense to do what you're talking about, to cut down on buffets and not have big cruise ships. But there was cruise ships that were leaving, in April and May when we were at the height of this thing. People were still getting on cruise ships. So, if the market forces are there, then it's going to happen, unless the rest of us vote all the politicians who said yes to it out and get all new ones who will say no.
Right. My last question here is, now that we're in the grip of the COVID pandemic, what do you think we as a world can do better to deal with the current pandemic and to prepare for the next one?
Yeah, I mean, I think, I feel like the biggest problem right now is not just containing the pandemic. It's really about just the huge erosion of trust between societies, across borders, and within societies. Between people and institutions, between one country and another. An erosion of trust in international institutions and international collaboration, even as a thing that people want to do. So I think that, to me, is the most pressing need, is to rebuild that trust. And, the only way we survive these new pathogens is by working together collectively. It's the only thing that works. We have to change our behavior. We have to rely on our friends and neighbors and strangers to also change their behavior. So you have to have that trust.
Absolutely.
And that's the big missing piece right now.
Yeah, I think that this is a really important point in terms of concluding our interview today. It's really important that we focus on building trust and relying on each other. We are not going to get through a pandemic without relying on each other. So I am going to turn it over to Suzanne, who is going to provide closing remarks. But I just want to say before I leave that, Sonia, it's been wonderful, fascinating. I loved your book. I found it utterly fascinating. It was hard to put down. And I really appreciated you being here tonight to speak to us and to give us your very thoughtful insights to some of these very important pressing questions, particularly right now. So thank you.
Thank you. This was a pleasure. It was really lovely. Thanks.
I think you're muted, Suzanne.
Okay. Thank you. Sorry. I feel like every Zoom call, it's like that. Everybody's like, oh, you're muted. We can't hear you. Sorry. Anyway, thank you both. Thank you so much. That was a really awesome discussion. And I think that point about trust is really, that hit home, right? We really do need that. It seems like on every level, not even just about the pandemic, just everything. And especially about science. I think what you said about that is that we have some work to do. Anyway, we hope that all our viewers enjoyed the discussion as much as we did. And we'd love to hear your feedback. So there's a link in the chat box and you can give us feedback. What would you like to see? Do you have suggestions for book titles, discussions, frequency of discussions, whatever you want to see, whatever you want to tell us, please do, because we're doing this for all of us. So please let us know. Next week is Science Literacy Week. I can't believe it's already Science Literacy Week. It's nearing the end of September. Our Fall Reads program is kicking off with another book, Ed Struzik's book. It's called Firestorm, How Wildfire Will Shape Our Future. Again, could it be more timely, given that the entire West Coast is on fire? And that book is complementary to our October 4th event, which is it's called World on Fire, The Science of Living with Wildfires. So again, super timely, and we hope that you can join us for the book as well as for the event on October 4th. And you can get more information on the website on that. So there should be something in the chat box about that, and certainly check out our website. Before that October 4th event, we have our fall program, which starts on Thursday, September 24th. We're very excited about that. It's the science of fermented foods and learning how to pickle things. So a do-it-yourself demo, and we're going to learn how to pickle. I think I can hardly wait. Honestly, it's going to be great. You can get more details on all of our upcoming programming on the website. And I just want to say thanks again to everybody. Thank you for joining in tonight, and see you next time. Bye.